Okay, welcome to lecture 3.8. Okay, here's where I left you in lecture 3.7. I said there's an identification problem with theta s and theta d, and if we multiply theta s and theta d by the same constant, we get the same likelihood function. And so what that means is we can't identify both theta s, theta d. We can only identify the ratio. Levitt and Porter, realizing this, they said, let's define theta, which was theta d divided by theta s. I told you that was about 8. Remember, theta d is probability of crashing when you're drunk. Theta s, probability of crashing when you're sober. It's about 8 times that. So that's what I did. I divided by, so I looked at all the p's, and in the last lecture I only focused on the one of the p's, p sub d sub s, multiplied numerator and denominator by 1 over theta s, did all the substitutions. That's what you get. You can do that again with the PSS, PDD, and here's what you get. I feel like one of those cooking shows. Okay. Here, we'll put it in the oven, and here's what it looks like. Okay. So I've got that. This is when we substitute in theta for theta d divided by theta s. Here's what it looks like. Okay. Now, we also have, now before I said pretend that a magic genie told us that what the value of theta, the value of ns and nd were. Okay. The problem is there's also an identification problem with ns and nd. And in particular, here's what happens. Suppose I told you that some value of NS and ND, what I think I put it on that last board, 247 and 58, something like that. Whatever the values are that you come up with, NS and ND hat, let's call them hat, and suppose they maximize the likelihood function. Turns out there will always be I'm going to show, there will always be another set of values for NS and ND that will tie in the likelihood function. And what you can do is you multiply them both. By the way, all the problems we have so far is where you multiply two parameters by the same constant. Other times we'll show that you can add the same constant to two different sets of parameters. That doesn't change things. Or sometimes I think you can... well, we'll see. There's various ways you can manipulate those parameters, and you can show that the same new set of values must exactly give you, must also maximize the likelihood function. The new value of the likelihood is going to tie the old value, and so if that happens, the likelihood function is not identified. By the way, another way to do it, how do you ever know? Well, one, you can always verify. You can show sufficient conditions. Why don't you just try to maximize the likelihood function? So you do one of those optim or maximize, whatever the command is in R that starts doing the hill climbing routine. If there's an identification problem, it means that that the likelihood function does not look like a mountain that's concave with one point that maximizes. It may be a ridge with a set of values, or maybe a plane with a set of values. When that happens, it turns out you will not be able to invert the Hessian when that happens. So whenever you have an identification problem, I said, a sufficient condition, a necessary condition is just run one of those optimization problems, and if it gives you an error message, that will also tell you that you have an identification problem. But back to this case, okay. The NS and ND also have an identification problem. In particular, I'm going to do the same trick. So I'm going to multiply, suppose that whatever value of ND and NS we have, let's substitute in those values. Now let's multiply them by the same constant. And let's multiply, I'm going to choose 3. Before I chose 0.7. I can choose any constant. To make it very simple, I'm going to choose 3. So let's multiply. You tell me whatever value you have for ND and NS that maximizes this likelihood function. I'm going to take your value for both of them and multiply both by 3. And here's what happens. So whatever you told me for ND, I'm going to multiply by 3. We have ND squared. So I'm going to multiply both of those ND terms by 3. That's going to give me 9. So when I use my trick, I'm going to multiply whatever numbers you tell me, I'm going to multiply them by 3. We're going to multiply the old value here by 9. Same thing here. We have 2 ND squared terms. I'll multiply those by 9. The value you told me for ND, I'm multiplying that by 3. And then you told me a value for NS, whatever it was, I'm going to multiply it by 3. Notice 3 times 3 is going to be 9. And then whatever value of NS you gave me, I'm going to multiply it by 3. We have 2 terms, NS, that's NS squared. So I'm going to multiply that by 9. Here again, the we're going to have, if we just multiply numerator and denominator by 1/9, all these 9s are going to cancel out. And we're necessarily going to end up with the exact same P as we had before. Same thing's going to be true if we do this with PDS, same thing PSS. So that means in this likelihood function, we're going to get the exact same value. Okay. So for that reason, NS and ND are not identified. However, as we talked about before, the ratio of NS and ND is identified. And so what Levitt and Porter do, let's see, I use green, let me use red now. Levitt and Porter define N without a subscript just equals ND divided by NS. Okay. Once we do that, we're going to try to rewrite these terms in these P terms in terms of N. Okay. So the way it looks like, if we want to make that an N, the way to do it is divide every ND by NS. So let's see if this works. Multiply numerator denominator by NS squared. You know what? Let's try it on this one. I got green marks here. Let's see if it works here. 1 over NS squared, 1 over NS squared. And what we are going to get is, okay, let's see. This case, we're going to get N squared. In this case, we're going to get N, again, same thing, N squared. In this case, we're going to get ND divided by NS, and then here, let's divide that by NS, and that's going to simplify to 1. This is going to simplify to N. This is going to simplify to 1. Okay, so this, and this one, we're going to get ND divided by NS is going to be N. NS divided by the other NS is going to be 1. And I'll tell you what, I'm going to rewrite this. I think I'm going to stop there. So I'm going to do the calculations, rewrite these p terms in terms of n and s. Okay, so now on lecture 3.8, so I will see, that'll end 3.8. I'll see you in lecture 3.9.